So we're going to go on to the last three exercises in Fraction Cabinet A. Drawer 7 is improper fractions 1. Typically we wouldn't write things out in proper fraction format, but we need to give this as an introduction so that the children can explore it in a way that's simple. When I introduce this exercise, I like to use two materials that are of a similar, if not identical format, but are two of a set. So from the fraction puzzle and the fraction magnetic puzzle, I've taken the family members that I need. So we can have 8 members of the 7ths family, but then we have an improper fraction. It doesn't really make sense to have more family members than you have members in the family, but sometimes that's the way it ends up. So here the child can easily see as they set it out that they have 1 whole plus 1/7. We don't say that, but that's implied from all of the work that they've already done in the fractions. Also notice the little space so that you can easily see the 8/7 as well. 5 and 3 is 8. Same thing with the 6/3. There's 5/3 plus 1 more, so you can just sort of see what you're seeing there. And when you come to things like 2/4, it becomes much more obvious that this is 2 wholes. Again, we don't point that out. Some children may discover it, and that's wonderful. You know that you've been encouraging use of the materials in the right way if that happens. But that explicit understanding can be taught later if the child doesn't discover it. Now, improper fractions 2. This is the way, of course, that we usually encounter an improper fraction, which is by adding 2 proper fractions together. I have 5/6 plus 5/6. Oops, I put 1 more there than I need, so I'll get that out of the way. So I've got 5/6 plus 5/6, which is 10/6, but it is also 1 whole plus 4/6. We're not working on simplifying. We're not working on changing it into a proper fraction at this time. We're just exploring and introducing the idea that sometimes when you add 2 proper fractions together, you will end up with an improper fraction. And then here again the same, 3/5 plus 3/5 equals 6/5, or 1 1/5. Now the last tray that we're going to do is fraction sets intro. If the children have been working with fractions in the way I've already shown you, this won't be an introduction, but it's an introduction to doing it formally with numbers. So this is the last exercise in Fraction Cabinet A, Fractions of Sets Introduction. If the children have been working with using cubes with the fraction stacker, this is not their first introduction, but it does formalize the way that they can do this. It depends on the age of the child how difficult you make this exercise and what recording is involved. So all that's in this drawer are numerals. So I have 9, so the way that I start is I set out 9 cubes. And then what I'm going to do is I'm going to find how I can make fractions of this set. So one set of 9 is 9. That's not a fraction. This represents 1 whole. When I attempted to put equal numbers of cubes on my half sections, I found out I couldn't do it. When I attempted to do that, I had an unequal number. If I have unequal numbers, it's not a fraction. A fraction is a certain number of equal shares. Here the way that this is calling back to the connection between fractions and division. So 1/3 of 9 equals 3. And I can write that out. And I can even have some paper set up where the child writes the 9 on a space. I have the word of written out, and then I have a place to write the fraction, and then a place to write the answer. So so it would be a place to write the fraction, a place to write the numeral that you're using, and then the answer. So 1/3 of 9 equals 3. When I come down to the fourths, I wouldn't be able to distribute them evenly. Wouldn't be able to distribute them evenly here. Would I be able to distribute them evenly with the sixths? Nope. I would have to get all the way back down to the ninths so that I could distribute them evenly. So 1/9 of 9 equals 9. That would be the only equations that the children could do here. Now with 8, of course, they're going to have a lot more options. When they did 1/2 of 8 equals 4. They would not have been able to do the thirds. Here what we have illustrated is the fourth. 1/4 of 8 equals 2. It's the number in each equal share. We would skip this, we would skip this, we would have to go all the way down to the 8 to get the next one. Now, what numerals to have in this drawer? Obviously, 9, 8, 10, 6 would be good options. Would you have something like 1 and 5, where you would have either, in the case of 1, no fractional equivalent at all, or in the case of 5, only 1. It depends on the level of difficulty that the children in your class are ready for. If they are very young children, if they're just learning to master fractions with the use of symbols, I wouldn't include these at all. I would only include the ones that they can divide out into sets. So we've completed Fraction Cabinet A. The reason that I have it here is to show the way that it is related to starting into the operations of Fraction Cabinet B. We did introduce adding fractions in drawer 6 of Cabinet A, and then we added fractions again in drawer 8 where we created improper fractions. Please notice that in drawer 6 we did not create any improper fractions. All of the adding resulted in that the sum was still a proper fraction. Only when we got here did we have improper fractions. So now we're finished with this cabinet and we're moving through our operations. These are all operations with like denominators, so the actual operation, moving through the operations is pretty simple. There's no need to find a least common multiple or anything like that. So we simply manipulate our materials in a pretty straightforward way. 1/8 plus 6/8 equals 7/8. And notice how I've grouped my 5 here so the child can actually see that 5 and 2 is 7 without having to count. Now in our addition cards, one of the things that you'll notice here again is that even though we have some that will create an improper fraction, we're not overtly working on simplifying or doing anything like that. If the child recognizes that the fraction is improper, if they realize that when they've got, I lost it. Well, I thought I saw an improper one in there. I usually have 1 so that if the child is, oh, there we go. So if the child recognizes that 9/8 is an improper fraction and starts talking about it, we can talk about that then the answer is 1 whole plus and 1 and 1/8, 1 whole and 1/8. But unless they bring it up, that's not something that we worry about at this stage. Then, of course, with our subtracting fractions, very, very simple. You can illustrate this in different ways. 6/9 minus 2/9. You can move them away completely. You can flip them over and say this is all that we have left, so we have 4/9. However you want to illustrate it is it's pretty easy to do it that way. Again, anytime I've got more than 5, I'm leaving my gap. So when I have completed these, this is what the work would look like. And then the last piece that we're doing is our multiplication of fractions. Obviously, because we are confined by the work that we're doing, we have to use pretty small fractions to start with. So 2/10 times 4, I simply set out 4 sets of 2/10, and then what have I got left there? Again, I can do a little bit of grouping. I can say, let's find our 5, and then without counting, we should be able to see that our product is 8/10. And notice, keeping track of my rubber bands again. So the last exercise that can be done with the kind of fraction materials that we've been using is dividing fractions with like denominators. This is the last one of our exercises where we're confined to like denominators. We're only working within each problem with one fraction family. And so, of course, it's pretty straightforward. If you have 6/8, you can easily divide them into 3 equal groups. You can set one out at a time if you need to. If you can just see it visually and group them, that's fine. You can group them horizontally. You can group them vertically. Obviously, the answer is just how many are left in your single equal group. Now, when we're doing this, we have some different options. If we do want to set out skittles or something to indicate the 3, we can do that. So we would have a skittle set out, and then we give 1 to this skittle, 1 to each of the skittles, and then the amount that each skittle has is what goes here. The only reason I'm not doing it that way is that my Skittles got taken out of my cabinet before I was filming. We'll see if I can do that for some still visuals to illustrate that. But that is one of the ways that we can tie this division of fractions back into the division that the children are used to from working with the golden bead. The idea that what you're doing is giving 1 equal share to each person. The Skittles look like a stylized version of a little person with a head, and so that gives them something to kind of wrap their head around, because division is the most abstract of our operations and can be the most challenging for the children to understand. So the second part of Fraction Cabinet B is not going to be able to be used with the kind of materials that we've been using so far. This is unlike denominators for the rest of the cabinet. The middle drawer is an introduction to unlike denominators, noticing how fractions with unlike denominators compare to one another. Then we're adding fractions with unlike denominators, subtracting them, multiplying them, and dividing them. So things are going to get a little bit tricky. So how can we do that? How can we show something like fractions with unlike denominators? Well, one of the best ways to do it is using materials that have a transparency factor to them. So here we've got sixths. We have 5/6 and 1/6 equals 1 whole. We can show that in the same color if we want to, like this. I know I've probably got a little glare going on, so I apologize for that. But one of the things that can happen is if you've got that transparency factor going on, you can take a half and compare it and even add it in this way. So I have 1/2 that I've added to 1/6. And because of the transparency factor, you can see that 1/2 plus 1/6 equals 4/6. So it's pretty easy to see that. Now you can also see that if you've got thirds, that works pretty easily with this. So we've got 2/3 plus 1/6 equals, if you can see through, you can see the 4 here, 5/6. And subtracting gets pretty easy. So if I were to want to subtract 1/6 from 2/3, if I've taken this away, what's left? 3/3. Now these transparencies are only one of several that are available. These are very inexpensive. They are available from AIMS, AIMS. And one of the most beautiful things about them is when we decide to start doing things like multiplying. Now, before I do that, I'd like you to think about your own experience of fractions. And I'd like you to think about, how does one multiply fractions that have unlike denominators? If you're like most folks, you will remember a little mnemonic about doing some flipping of some very abstract numbers that don't mean an awful lot. If I ask you to multiply 1/2 by 2/3, you can probably do it. However, can you tell me why it works the way that it did? If you can't, you don't truly understand what you've just done. I'm going to multiply 1/2 by 2/3. Now, I would have already talked to the children about the fact that in all math, but especially in fractions, this symbol means of. If I multiply 2 times 3, I take 2 of the quantity 3. 2 times 3 is 2 of 3, or 6. But now, I'm not going to take 2 of something. I'm not going to take 3 of something. I'm not even going to take 1 of something. I'm going to take less than 1. This is 1. Here's one unit. And this is 1/2. So I only want to take 1/2 of 2/3. Well, that's not going to work very well, is it? I mean, you might be able to figure out what you have there, but it certainly isn't obvious because everything isn't the same. Remember, in fraction families, every member is exactly the same size. Here we have 2 members and 2 more members. Well, that doesn't work. But what happens if I do this? Now, do I have a fraction family? I sure do. I have 6 because we have 6 equal amounts there. But what did I take? I only wanted 1/2 of 2/3. So what I'm going for is the shaded portion. I don't want all of 2/3. I only want 1/2 of it. So 1/2 of 2/3, or 1/2 times 2/3, is 2/6. I can also then reduce that down, but that's another lesson for another day. So be sure, as you move into more complicated work with the children, that you have materials that are going to help them do that with as much ease and simplicity as you did with the simpler fraction operations. So you may wonder where some of this came from. You may wonder whether or not this is an entire fraction curriculum. Well, the answer to the second one is no, it's not. And I believe very much that one of the ways that I show respect for you and your inner teacher is by not just telling you what to do, not by just giving you a sequence of exercise to use with materials, but by helping you know how I think about these things and adapt them when I'm working in a classroom with a set of children. Up through this cabinet, most of the exercises that you've seen here are from a combination of different trainings that I've taken, as well as some different commercial materials that I have studied. This is kind of the next steps that I have gone to. As I've realized where the gaps are with the children, I am creating the next set of fraction exercises. These haven't been created yet. I am in the process of testing some of them out. I happen to find these little cabinets that in a sale at a drugstore or something, and so I decided I wanted to make one more final cabinet. And how I came up with that was based on where I saw children having difficulty. Fractions of sets. This is one of the things that children need to be able to do. They need to be able to do 1/2 of 18. They need to be able to do 4/5 of 20. Even in the age of the Common Core, those are not considered that difficult of problems. So they need practice with that. They also need to understand how the practical applications work with the other things they're doing. A quarter, 25 cents. 1/4 of 100 is 25 cents. That's fractions with money. A half an hour, 30 minutes of a 60-minute hour. That's fractions with time. Fractions of years. A half a year is 6 months. School year is about 3/4 of a year, 9 months. That's fractions with time in a bigger scale, years. Fractions of gallons, fractions of yards, fractions of dozens, a half dozen eggs. And Fraction Cabinet C exercises, that's my label. So these are the next sets that I believe would be useful for the children to use. Unfortunately, we have way too many Montessori classrooms that are forgetting that by the time the children are adolescents, they need to be applying what they've learned. They need to be going to the place where they are using this information. They don't want to just be adding more information. They want to use it. They want to contribute. They want to interact. They want to see how all these things fit together. If we're going to accomplish that, sometimes, especially in public schools, we've got to be picking up some pieces. Personalizing the exercises that you have on your shelves, making them more interesting and more useful to the children is one of the ways that we set them up to succeed in the next steps.